see here is that these points are equidistant away from that vertex. Like it's one smaller, one larger, and that's really the most helpful thing when it comes to graphing. So like here's another point, 1, 12 that you can see on the graph. And then the idea is that it's reflected over this line here. Let me change the color of that. Settings here. Let's change that to dash line black. We'll go there. Okay, so the idea is that this 112 is symmetrical over here to the right, and you don't have to find all the points. You just have to find enough that you can go left and right of the vertex. Sorry, I got the wrong point there. 512, like that. Good. So here's what your teacher expects when you graph, and this is why we're doing this. They want to see the vertex. They want to see 2 points left of the vertex, 2 points right of the vertex, and then they want to see a nice smooth curve drawn, not straight lines, a nice smooth curve drawn. And then I like seeing this axis of symmetry, but it's only there if it feels like it helps you to visualize that.
Okay.
Okay. So the key here is to be able to graph the vertex first and then these other 2 points. So we're going to use the table method to do that. There are other approaches.
I just got home. So
okay. Yeah, do you need a minute or two to get set up, or you?
I think it should already be set up, maybe.
Okay. It's okay if we take 1 minute and you get settled. We'll have plenty of time to get through everything that is important here
I
today.
can see what you're doing right now.
Okay, fantastic.
Okay.
All right. So I'm gonna go back to the other screen here. So in terms of graphing, let me just make sure. Looks like a participant left. Okay.
I think I'm back now.
Yes,
right?
you are. You are.
Okay.
Are you able to see my screen?
Yes.
Okay. So in terms of graphing, these are like absolutes. You will always have to do the following. You will have to graph the vertex, and then 2 points left of the vertex, and 2 points right of the vertex.
Okay.
Okay, these are absolutes. Okay, and then really it needs to be a smooth curve. Okay, it's not okay to draw sort of these lines like that. That's not what they want. They want to see a nice smooth. You know, they know you're not an artist. It's not like that. It's just that you have to do better than just connecting them. Now, some potentially other things that you will need to graph, depending on the problem, is a y-intercept.
Okay.
And x-intercepts, could be more than one. Okay. And then maybe down the road, some intersections and some shading. But that's down the road. Okay.
Okay.
All right. So let me give you a, if you kind of got this down, of course, I'm going to send you the notes at the end. We can then talk about, look at a new problem if you're ready.
Yep.
Okay. So here's a new problem. Y equals 2x plus 3 squared minus 4. Could you tell me the vertex for this problem, please?
-3, -4.
-3, -4. Good. Now, the table method. Okay. Your table needs 5 data points.
Yep.
The middle one, not the top one, the middle one is the vertex. Don't put it at the top. That'll be confusing. Then you need 2 x values larger and 2 x values smaller. Okay, now this can sometimes be awkward in the negative space. Okay, but make sure those are in increasing order. All right, so now my approach, the thing that I've grown accustomed to doing, is I just take one of these x values, either -2 or -4, because of the symmetry. You're going to see that here. You're going to see that these produce the same y values, but we're going to put those into this equation.
Okay, so just plug it in for x, essentially.
Yeah, so we'll do -2. -2 plus 3 squared minus 4. So order of operations here. -2 plus 3 is 1. 1 squared is 1. 2 times 1 is 2. Minus 4 is minus
-2.
2.
So
Now we'll do it for the first few, or at least for this one, we'll do -4, but you will see that it's exactly
it
the
should be
same.
the same, right? Because
Yes.
like they're in the same areas, like in
One's
relation to the vertex.
yeah, one's right and one's left, so there's symmetry. That's really nice. Okay. So this is -1 squared, which is 1. 2 times 1 is 2. Minus 4 is minus 2. And there similarly will be symmetry between -1 and -5. Okay, so you can again try those values. I would try the ones that are easier if there is such a thing. So 2 times -1 plus 3 squared minus
So
4.
then 2 squared is 4 times 2 is 8 minus 4 is 4.
That's right. All right. So now,
Okay.
now you're ready to graph. All right. So I'm going to copy this table down and we're going to graph. Oops. Okay. So you kind of want to judge where you are. You're like, all right, -3, -4. That's kind of like if let's just say my axes were here, our origin was here, that's going left. So you want to make sure you leave yourself enough room. 1, 2, 3 left, 1, 2, 3, 4 down. Okay. And then just get your other points here.
Okay.
-2, -2. And then by symmetry, you can get that other one. Okay, and I know you want to, you want to make these big lines, but you really just need a little one to start out. And then -1, 4, 1, 2, 3, 4. And then, if you, oh yeah, it's symmetric about that. 2 to the right, so it's 2 to the left. This is your
Okay. So then, yeah, it's the same graph I ended up with.
yes.
Okay.
Okay. All right. So we should do some other ones here. So some other things that you might see that, I mean, that's kind of the basic case. You're in an honors class. You're gonna get harder stuff than that. You're gonna get problems like this, like y equals -1/2 x -1 squared plus 4.
Okay.
Actually, let me make this different because we might do something else with this one. Let's go 8. Yes, that'll work.
Okay.
Okay. What is the vertex of this one?
1, 8.
1, 8. Okay, so that's great. It does open down. That negative in front up is down.
Yep.
So here's where you're potentially gonna have your first issue. So if you go to your table, x, y, all right, 1, 8. So that means I'm gonna go 0, -1, 2, 3. Okay. Well, let's just try 2 because 2 is kind of nice. It's positive. So it'd be -1/2, 2 minus 1 squared plus 8. 2 minus 1 is 1. 1 squared is 1. -1/2. So this one's not terrible, but that's not really a nice point.
Yeah.
Okay. So let's go to 3. Maybe 3 is better.
And then it would still be symmetrical, right?
There's symmetry there, but what I'm gonna show you here shortly is that sometimes you don't necessarily always want to use every point. So like 3 minus 1 squared is 2 squared. 2 squared is 4. -1/2 of 4 is -2 plus 8 is
6.
6. So that's a better
That's a better point
point.
to use than 7.5.
Yeah, and the problem is you're like, well, what do I do with you just remove it.
Yeah, you don't use it.
You don't use it. At least you're trying to make a nice graph. And that kind of helps you to realize, okay, I'm going by 2s now instead of by 1s. Okay.
Yep.
So now you got to go and try. I don't know, I'm gonna always try the positive ones. -1/2, 5 minus 1 squared plus 8.
4 squared 16, so that's -8 plus 8 is 0.
0. Good. Okay. So now this is a better looking graph. Okay, plus we got some additional information we didn't expect, which are the x-intercepts. So we're going to graph that now. If you have graph paper, I know it's tedious, but it's good to actually
Graph it.
yeah, on there. Now, I almost made the classic mistake of not deciding kind of where this is graphically, like 1/8's kind of up here, and then we're going out 5 and left 3. So just try to figure out where your points are going to go before you make your crosshairs.
Yep.
So we got 1, 8, 1, 2, 3, 4, 5, 6, 7, 8. 3, 6. And so again, that because of that line of symmetry, you can go get that other point real quick. 5, 0 minus 3, 0. And now you have enough. Again, just, and it's got to be nice and smooth. It can't be straight lines.
Yep.
Okay.
And then the other thing, so they're apparent. So I think that we're gonna have to describe the graph. So it would be like a parabola, reflected over the x-axis, and then I could get like the line of symmetry.
Yeah,
For,
we can talk about transformations as well. That would be good to do next. With
it's
this.
just like because I don't know why they make us do it, but you have to describe the graph.
Okay.
So
Yes. So also here, label points. I didn't do that on the last one, but that's usually pretty important.
Okay.
Label your axes, your grids, X and Y.
Yep.
-1, 6, 3, 6, 5, 0.
Yep.
And then like you said here, we can go back to the original. We can just do that right here. It was y equals -1/2 x minus 1 squared plus 8.
So
And
then the axis of symmetry equation is isn't it y equals?
it's always x equals
Oh yeah,
because it's a
x equals
vertical line.
yeah, so x equals 1.
Good. Okay.
Then it's a it's a U-shaped parabola, right?
Well, so that's redundant because it's already assumed to be U-shaped. So if you want to say it's either opens down
Oh, okay. So then
or up,
okay.
min max, that kind of thing.
Okay.
It's like, I don't know, have you guys graphed absolute value?
Yeah,
So
that's what I was thinking
those are
about. Yeah.
those are V-shaped, and you don't have to say that it's assumed to be known.
Okay.
Like kind of like saying a straight line. A line is already straight.
Yeah.
But that's okay if you do. Now there's 4 transformations here. The first one comes from the inside part here. Do you remember that from the other night?
Oh yeah, it shifts the graph over 1 to the right because it's the opposite.
Right. And then the next one is this 1/2, and
It
because
means it opens down.
the
right?
the negative is the flip. The negative is the flip.
It has a vertical. Isn't it like it's a stretch, right? Or is it a
So
shrink?
it's a shrink is good.
Oh,
Stretch
because
is
it's
good.
less than 1.
Exactly. And you got to be careful about this factor. This isn't completely correct, but we'll just go with it for now. And then the last one is that +8.
It moves up 8.
Up 8, yeah. Okay. And
So
that's
then I
kind of
can write all of those as ways of describing the graph.
the transformations have to be in a certain order.
Okay.
Kind of everything else is like
But like, could I write
characteristics.
vertical stretch by 1/2 as a way of describing the graph?
They usually want them in terms of transformations. It'll say like list the transformations of the graph.
Okay.
It really depends on the teacher. You said you had some quiz questions that you might be able to send over at some point. I'm happy to look at those to
Oh yeah, they're
help.
from an old quiz, but
Yeah.
it's like the types of questions that matter, right?
Yes, just seeing the style really helps me to know
Okay.
what they are looking for.
Let me see if I can. So then. And let me go see if We can email this to you. I'll be right back.
Sure.
Okay, I think I should. Yeah, I just sent it.
Okay. All right, I'll take a look at that. So while I'm looking at that here, I've got a problem for you to try.
Okay.
There's some things here that you may not know how to do, which is okay. I don't know if they've been covered in class or not, but I'm looking for all the stuff we just talked about.
Okay.
You know, the graph, you know, a table.
Okay. Because I can also send you pictures of the homework that
Yes,
was assigned.
please do that as well. That would be really good. It's always good for us to do problems from your teacher rather than Matthew making them up because he
Yeah. Okay. So then I'll also send you that. So it did send. Did it send?
Yep, got
Okay.
it. I'm looking it over now.
Then that sends you the standard form picture of the homework, and then I'll
Okay.
send you the um what is it, the vertex form.
Vertex form, yeah.
Mm, Okay. Then email. Okay. Okay. So then the images of the homework are sending now.
Okay, sounds good.
Okay.
So I'll give you some feedback on what I see on the quizzes while I'm waiting for that to come in.
Okay.
Um, the you did really well on this one, which is great.
Yep.
But the style here is the teacher likes to group them. So they give
Yeah.
you you know, probably you had a homework assignment on determining whether the sequence is arithmetic or geometric.
Yep.
Then you had an assignment where you had to write the equation. And then 8 is the kind of probably the differentiator between students that get like an A or a B on the test or quiz because it's a for lack of a better word, a story problem or a
Yep.
I don't
Word
know,
problem.
word problem. Yeah.
Yeah.
And but more so than that is you have to use some words. Like it says interpret. So this interpret is like a common thing you'll see in math classes. They want you to write a sentence, a succinct sentence.
Okay.
And they're looking for certain keywords, but this is good. 9 and 10 are probably just like what you saw in homework.
Yep.
So that's good. That's good here. Okay, so I did
Yeah,
see.
she does group it.
That's good. Some teachers don't, especially in college. It's all over the place.
Yep.
All right, now, did you discuss even, odd, or neither?
For
So it says here in exercises 5 through 12, determine whether the function is even, odd, or neither. And that's an important thing, but it's very different than what we've been doing
we
right
may
now.
have, I was absent that day.
Okay.
So
Let's have you do a couple of more graphing problems here. Let me just look through this a little bit more, see what else I see. There they 3, 4. Symmetry, domain and range. Yeah, you already
okay,
did
so
domain.
we did cover even and odd.
Okay.
It's in like the notes
All right.
here.
Let-
So it's just the
let-
function y equals fx is even when f of negative x equals f of x.
yeah. Okay. So we're gonna do this. We're gonna do even and odd right now because it won't take that long, and then
Okay.
we'll come back to some graphing.
Okay.
So let me rather than like doing these tests, we're gonna show graphically what it means for a function to be even, and I'm gonna show you one that is even. So this is even. Okay, even is what is called y-axis symmetry.
Oh, is that where it's on it y equals 0? Yeah, y equals or x equals 0.
Yes, and it has to look the same on the left and the right.
Okay, so if the axis of symmetry is equal to 0 and it's equal on both sides,
Yes,
then it's even.
yes.
Okay.
Okay, so the odd ones are a little bit harder. You really don't know enough yet to see these, but I'm gonna show you one here first for that. Actually, let me go graph it in the other window and then I'll snip it in. That way the
Okay.
graph is nice. Just a moment here. All right, so I'm snipping this in now. Actually, let me zoom out a little more. Okay. So this graph I put in here is incomplete, but there's a reason for that. So an odd function has what is called origin symmetry, or
And
sometimes
that's when y equals, it starts at the origin of the graph or 0, 0.
it does, and sometimes it's referred to as point symmetry,
Okay.
but not all of them do. These examples will. Now, this graph is incomplete, as I mentioned, because I want to show you it's actually more of a rotation symmetry. So you take this graph up here and you rotate it about this point, so it ends up looking
Yeah, it's
like
not, that's a special kind. That's like it's not a square root function. It's a,
it's a cubic.
yeah,
Yeah, and I didn't know if you'd seen that or not yet.
yeah.
Um,
We've seen those, but we didn't really go in depth on them.
right. So let me give you another even one to see, and then we'll talk about another odd one, and then we'll look at exceptions.
Yeah,
All right.
because
So
then, so that's even.
this one is even, yes. And it's good to draw that line just to confirm that.
Yep.
The following one is odd. It may not look like it at first glance, but it is odd. So let me snip that in. Okay.
Yeah, isn't that odd? Because is it? So do odds? Are they typically not parabolas?
They're never parabolas. So odd functions typically, are you familiar with the quadrants?
Yeah, 1, 2, 3, and 4.
Yeah, they're typically in 1 and 3 or 2 and 4, typically.
Okay, so if it's not a parabola, it won't be even.
so that this is a line. Lines are often or could be odd functions. There's a few
Okay.
odd lines. Okay. But the most of them are not. So like let's look at this problem here. This is 15. 15 is neither or neither. And it's better to look at them like as a checklist. Is it even? Does it,
No.
and you say no or X. Is it odd? Does it reflect over this point right here? And this one might
Oh,
be
so it
hard.
has to start at 0, 0.
That's not the best definition. It's got to be a reflection. So, or I'm sorry, a rotation. So like if this were odd here, I'll make it odd right now. This would be odd.
Oh, so it has to be the same thing but mirrored in the opposite quadrant.
It's a rotation,
Yeah.
not a
Okay.
mirror. A mirror is different than a rotation. So
Okay.
odd, no. So then it must be neither. So it's like no, no, yes. You stop when you see a yes.
So it's a checklist.
Exactly.
Okay.
Okay. Here's one that is again neither. And there's a reason I don't want to like have you guess because you got to get this down. I don't want you to be unsure. So again, you even is it mirrored over that line right there? It's the same on the left as the right.
No.
No. So then we go to odd, and you draw a point there.
No.
And again, it's no, so therefore it must be
It must be neither.
neither. Yeah. Now the reason you're learning this is you can use these symmetries throughout a lot of math, and it's good if you know them.
Okay.
So again, is this even?
That's odd, right?
That's this one. It would, if it were odd.
Oh, wouldn't it have to? It would have to go through 0, 0.
Well, a lot of them do, but so here's how it would look if it were odd. It would look like that. That's one possibility. If you excluded that, I'm sorry, that's the wrong direction. It would look like that, but that's not even a function. So,
Yeah.
so
So it's neither.
for now, you can just say it has to go through 0, 0, but that's not the complete definition.
Okay.
Okay. So now, now that we've done that, there's the non-graphical way to do it. Okay, so we're gonna look at number 5. Actually, we're gonna look at 6 first. 6 first, okay. And I'm gonna change this to f of x for all of these. Is that 3x squared or minus 3x squared? I guess it's 3x squared. Yeah. Okay. All right. So here's the recipe. You first evaluate f of minus x.
And I'm assuming this way is more complicated than doing it graphically, but if you can't figure it out graphically, this is the best way.
It's if you had a Desmos, you would just go and graph it and do exactly what we did. But on the test, you won't have that, so you have to do it this way. And it's a recipe. It's a recipe. So a lot of math is as a recipe. You do step 1, step 2, step 3, you get your answer. So this evaluates to 3x squared. Is that clear? The negative squared becomes
Oh yeah,
positive.
because
Okay.
yeah, okay.
And then you ask yourself, is this the same as the original?
So then
Is this the same as the original?
yes,
So if you answer yes, that means
it's
it's even. Yes.
and if you answer no, it can either be odd or neither.
Yeah. Yeah. So we're gonna do an odd one now, and we're gonna go to number 10 for that. Although
Okay.
I don't really like 10, but we'll do 10, and then we'll do another better one. F
Okay.
of x equals minus 1/2 x. First thing you try is f of minus x, so minus 1/2 minus x. And this equals 1/2 x.
X. Yeah.
And then you ask yourself that first question, is this, I'm being silly here. I need to just copy and paste.
No, it's not.
So it's not. So that doesn't, here's what that does. All that means is that it's not even.
Can't be even.
Not even. Doesn't mean that it's odd. It just means it's not even. So now this is awkward on here is the next thing you do is you factor out a -1.
And if you can factor out a -1, then it's odd.
Well, it's like I don't want to say this. So this one doesn't have a negative. This is why this one's really awkward.
So then would that make it neither?
Well, it's negative -1/2 x.
So, but then that's 1/2 x.
Right, but you have to. So I'm going to give you a better example than this. I apologize. This is so
Okay.
weird. But then you ask yourself, is the part in parentheses
The same as the original,
yes,
and so then it would be odd because
yes,
it is the same.
yes.
Okay.
And if you get no,
It's either.
then it's neither. So let me give you one that's kind of better, but it's beyond what you're doing, you know, in this part of the course right now. Let's
Okay.
say it's a 2x cubed minus 5x. Okay. So you first try f of minus x. So
So
2
then
parentheses
2
minus.
minus x cubed minus 5 minus x
Yeah.
cubed.
So
So then all the minus x means is you just make all the x's negative.
it depends on the exponent. So minus x to an even exponent is always x. And
No,
then
before you multiply it back out, you put the negative x in the parentheses.
yes, sorry.
Okay.
So that's what that means. It means replace x with minus x, replace x with minus x.
Okay. So then it can't be even because that's not the same.
So this
Then
is
if
where
you
it's easier
factor
to,
out the
yeah, -1.
-1, so it'd be -2x cubed minus 5x. Yeah,
So is this the same as
that
the
is the
original?
same.
So
Yes.
this is a better example of it being odd. Yes.
Okay.
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 All right. So now let's do a couple more here that are, so let's do another even one.
Okay.
All right. And I'm telling you this because I want you to know what to look for. It's always easier to do something if you know what to look for. So try this one. Tell me why it's even when you're all done.
Okay. So that says f of x equals -x squared plus 8. Equals -x squared plus 8. So make it all negative. So then f of -x -x squared plus 8. And then it becomes f of -x equals
So
x
make sure you
squared.
square first and then negate. Order of operations.
Oh wait, so then square first, so that's x times
X,
-1.
right.
So then -x squared plus 8. So it can't be even.
No. Is this the same as the original?
Oh wait, I copied it down wrong.
Okay.
Oh wait, yeah, it is. That's the same.
Yes, it is. So this is even.
Yeah.
All right. Let me give you another one here because they're just not giving you ones that you, let's have you try this one. So let's go, this is an example. Let's say f of x equals 4 minus 5x to the 4th plus 4x squared. I want you to tell me if this is even or odd or neither.
Then f of -x equals 4 minus 5 minus x cubed plus 4 times minus x. So then f of -x equals 4 times 4 minus 5x to the 4th minus 4x. So then it's not the same as it was the first time.
Well,
see.
you gotta value your exponents carefully. Okay, so
Oh, you got to square it first. You have to square it
yes,
first.
yes, you
So
can't.
then it would be plus 4x squared. So then it is even because it's the same as the first.
That's right. Okay, so now let's look at some examples of neither. All right, so let's look at number 5. So number 5 says f of x equals 4x plus 3. Okay. Now, just because I'm telling you, we still want to go through the steps. We still want to, you know,
Negative x equals 4, negative x plus 3.
so this is not the same as the original. So we say not
Yep,
even,
so
and you want
not
you
even.
then you factor out a negative from both.
Yeah, so then f of, it's still negative x, right? Negative x equals,
It's f of negative x. It's got to be
yeah,
written.
yeah,
Yeah,
yeah. And then factor out -1. So then,
from both. Yep,
yeah, so then it'd be negative 4x minus 3, and that's not the same either.
that's right. So
So
therefore,
it's neither.
it's neither. Yeah. Okay. Let's look at number 11. Or actually, let me have you try number 11.
Okay.
You will see that it is neither. But work that out on your own. If you have
Okay.
questions, let me know. I'm going to just step away for 30 seconds. I'll be right back.
Okay. F of x minus 2x equals 2x squared minus 7x plus 3. I think it's minus 7x. Yeah, minus 7. But there's an, okay. So
Sorry
then
about that. I had to
f of
he
negative equals 2 negative x squared minus 7 negative x plus 3. And then f of negative x equals, and then 2x plus 7x plus 3. So then that's not the same as the first one.
That's right. So it's
So
not even.
the factor out -1 equals -1 minus 2x.
7x. I'm sorry.
Yeah.
You're there. Okay.
So then you already know based off the first term that it's not going to be odd either.
That's true. So you don't even
So
have to go any
then
further.
it's neither.
Yeah. Just one small thing here. When a couple times you've done this, you really want to say negative parentheses or negative the quantity to indicate, because the way you're
Okay.
saying it reads like this, and maybe you're writing the right thing, but
Okay.
it's just a small thing.
Okay.
All right. I feel like you understand that pretty well now. You are going to get a quiz question that's, determine whether it's even, odd, or neither.
Yeah, I probably will.
And it'll be just like the one you just showed me. It'll be, A, B, and C, like that. Okay.
Okay.
So let's talk a little bit about standard form graphing.
Okay.
And we can look at some problems here. So let's look at I don't know. Let's go number 9. It says y equals -9x squared minus 18x minus 1. Okay. So first thing is to find the vertex. I think we did this last time. You have to identify A, B, and C.
Yeah,
Is
so
that
then
right?
A equals -9, B equals -18, and that's all you need. So then it's negative B over 2A, right?
Right.
Okay, so then 18 over -18 equals -1. Then you plug -1 in, right?
That's right.
So then
So just this is kind of like what we were just doing, but now with a number, -1
so then
squared.
so that's -9 minus or plus 18 is 9 minus 1 is 8. I got,
-9. Yeah, it's 8. Yes.
yeah, so then I got -1, 8.
Yes. So this is where you now go to the table.
Oh, so then it's this, so after that, it's the same procedure as the
Yeah.
other one. So then,
Now make some points here that I think are important here. Again, like too larger, too smaller, and because of symmetry, like choose wisely. Really choose
Yep.
wisely. Like do the 0 because 0 squared is 0. 18 times 0 is 0.
-1.
Yeah, and I'm almost done now. And I didn't have to do anything. So now I want you to evaluate either 1 or -3. Strongly
The
recommend
one's gonna
1.
be easy.
Yes. So please do
Then
that. Let me know what you come up with.
-9 minus 18 is 20 -27. So then -28.
Yeah. Now, in terms of graphing this, like this is where you really want to ask your teacher, like, how accurate do I need to be? Because
You probably don't want to graph the -28.
yeah, and you know, like they're looking now for the shape. Like, are you kind of in the ballpark? You know,
Yeah.
like okay, kind of there and there, and you know, like they know it looks really bad. They're just hoping you do too.
Yeah.
That you kind of get that down. Actually, that's really bad. It's down there. Okay, some other things that I can ask you about this. Let me grab this again here. So let me capture the key information so far. The key information is that the vertex is at -1,8. So what is the axis of symmetry?
So isn't it just the second x equals 8? Isn't it the second term?
It's the x value. It's always the x value.
Oh, x equals -1 then.
Yes. Okay, so that's the first thing.
Oh, because it's x equals.
Does this have a min or a max?
Um,
And if you're not sure, ask yourself, does it open up or down?
it'll
Eh,
open down because so
Okay,
it'll open down because -1,8.
good. Now, what is the max?
The max is a y value, right? So it'll
That's
be
right.
8.
So see how we consume both the x and the y value? Yeah,
Yeah. So
good.
if the x value is negative, does that usually mean it opens down?
No, it's because here's what you just asked me. If the x value is negative, so here's a negative x value. Isn't that possible?
Yeah. So then how would you know it? So would you have to graph it? Or would you have to like look at the points to determine whether it opens up or down?
It all comes from this right here, this a value.
Oh, it's the same.
It's the
Oh,
sign.
because they're
It's
both
the
A.
sign.
Yeah,
Yes.
because they're
It's
both A.
yeah. The sign tells you whether it opens, you know, negative means down, positive means up.
Okay.
Okay. Now the vertex tells you another important thing that we can talk about here. The vertex of this problem is -1,8, and we know that it opens down. We can now talk about domain and range real quick. Do you remember domain from class?
Yeah, so domain is all real numbers.
Now, are you writing it this way in
No,
class?
we just write all real numbers.
Okay. And how about range? Oh, that's right. You use inequalities. So range depends on whether it opens up or down.
Yep. So it opens down. So
So
it'll be
that
y
means
is less than or equal to 8.
that's right. That's perfect.
Okay.
Okay. Let me ask you for, since we don't have very much time left, let me snip in a graph here again and
Okay.
just ask you for the range of this one, please.
Oh, well, I wanted to know if you had any time tomorrow.
Possibly. Let me get back to you. Do you need a full hour?
Yeah, or just any amount of time, really.
Okay. Yeah, let me get back to you here.
Yeah.
What's the range on this?
Range is y is less than or equal to 2. I think
Okay,
that's
that's
what that
good.
number is.
That's good. What did you need to cover certain problems here? Something new? Give me an idea of what you want to accomplish tomorrow.
Kind of like go more in depth in the